Hello students, welcome to SmartKidz Tutorials. In this video, we'll be looking at the mind map or the concept map of a pair of linear equation in two variables, chapter 3 of class 10. And in this, we have learnt before that linear equations in two variables involve an equation in the form which is ax plus by plus c equal to 0, where a should not be equal to 0 and a square plus b square should also not be equal to 0. Also, a, b and c that you see over here, they should be real numbers. So we have two pairs over here. That is why we call it a pair of linear equations. a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where this a and b are actually coefficients of these two variables x and y respectively. Now x and y will not change, wherein we need to find the value of this x and y by solving. Either we can get it by using a graph, and is in plotting a graph, or by solving via algebraic methods that we can see on the left hand side. But before we go to find out how we can find out the values of x and y, let's brush up on a few concepts of linear equation. Each of these equations represents a straight line. Okay, so if you plot a graph, so that is what this statement says: each solution x comma y, that's how we represent in a bracket to show the coordinates on a graph like this, corresponds to a point on the line representing the equation and vice versa. What this statement is trying to tell us is that if we have a graph like this, where you have the y-axis and x-axis, and you have a straight line, this straight line represents the equation of represents a linear equation like this. Okay, and it is actually made up of infinitely many points. Okay, it is made up of infinitely many points. So this line represents this equation, and this equation also represents this line. That is what the last part of this sentence is trying to tell us, that it corresponds to a point on the line representing the equation and vice versa. What it means is that this line represents an equation and this equation represents this line. That is what it's trying to mean. So graphs of linear equations are always straight lines like this. As we said, linear equations can be represented either graphically, or we can find out the values of x and y, the two variables, either graphically as in the right hand side, or by algebraic methods as you can see on the left hand sides. So we have a system of simultaneous linear equations in two variables, which when we solve, we get the value of x and y algebraically as well as graphically. So we move to the graphical representation first, as in if you have a look at this, there are three different types of graphs that we can see. Here we have two lines crossing each other, and here we have just one line, and here there are two lines but they appear to be parallel to each other. And then we have some ratios that we can see in each one of them. So we'll address each one of them. What do they mean? Now we said we have a system of simultaneous linear equations. We have a1x plus b1y plus c1 equal to 0, and we have a2x plus b2y plus c2 equal to 0. If we take the ratios of just their coefficients, as you see over here, a1 upon a2, b1 upon b2 and c1 upon c2, from here, based on the relationship that they have with each other, we can conclude whether this set or this pair of linear equations, whether it will give us just one solution, or it will give us infinitely many solutions, or no solution at all. Have a look at the first figure over here. and we'll compare the ratios first, then we'll go to the graphs. Here we have two pair of lines. See why it says pair of lines, because each of these linear equations actually represents a straight line. So we have x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. If you notice over here, there is no constant in the first one. Okay, that means it will be 0. Now, what is, we have a1 upon a2, b1 upon b2 and c1 upon c2. So first it's noting down what is a1 upon a2, rather noting down what is a1, b1 and c1, and a2, b2 and c2. So a1 is 1 because the coefficient of x here is 1. The coefficient of a2, which would be this of this equation, that is of x over here, is 3, and hence a1 upon a2 is given as 1 upon 3. Similarly, b1 upon b2 is given as minus 2 upon 4 because the coefficient of y in case of the first equation is minus 2, and the coefficient of y in case of the second equation is plus 4. So hence minus 2 upon 4 would be b1 upon b2. And for the c1 upon c2, c1 we don't have a c1, that means it should be 0. c2 is minus 20 as noted down over here. Now the next step would be to compare these ratios and see whether they are equal to each other or not equal to each other, and which ratios are actually equal. Are all of them equal or some of them are equal? If you notice over here, a1 upon a2 is 1 upon 3, b1 upon b2 is minus 2 upon 4. If we divide this further, we'll get minus 1 upon 2, and then c1 upon c2 is 0 upon minus 20. That will remain that way. Now a1 upon a2 is clearly not equal to b1 upon b2, because this gives us 1 upon 3, and b1 upon b2, even if you reduce, will give us minus 1 upon 2, which is not equal to 1 upon 3. When a1 upon a2 is not equal to b1 upon b2, we say that this pair of linear equations is going to give us a unique solution. So moving on to the next one, if we look over here, this one, that we have pair of lines 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. Once again we compare it with our general form ax plus by plus c equal to 0, and we get a1 upon a2, b1 upon b2 and c1 upon a2. a1 upon a2 is 2 upon 4 from here, b1 upon b2 is 3 upon 6, and c1 upon c2 is 9 upon minus 9 upon 18. So if we reduce this further, 2 upon 4 will become 1 upon 2, 3 upon 6 will become 1 upon 2, and minus signs will cancel here, and 9 upon 18 will also give us 1 upon 2. So in other words, a1 upon a2 will be 1 upon 2, b1 upon b2 will be 1 upon 2, and c1 upon c2 is also 1 upon 2. In other words, a1 upon a2 will be equal to b1 upon b2, and it will be also equal to c1 upon c2. When all the ratios are found to be equal to each other, then we say that we have infinitely many solutions for that particular pair of equations. As in, for these two, there would be infinitely many solutions for the x and y. When we draw a graph, we will find that we will get only one line, because there are two lines out here which are coinciding with each other, as a result of which you can't see another line as you saw over here. These two lines represent these two equations. Here also there are two lines, but because they are coinciding with each other, you cannot see the second line. It's like saying the one line is superimposed on the other line, or one line on top of the other line. They share the points. Okay, we have learned that a line consists of infinitely many points. So these two equations share the points, as a result of which there is only one line that we can see. And when we have such a type of solution, infinitely many, we say that we have got a dependent system. Okay, we have got a dependent system. Okay, a system of two linear equation in two variables is said to be dependent if we get infinitely many solutions for x and y. The third one, now first one we got just one solution for x and y. Second one we saw that there are infinitely many solutions, something that we cannot count. In the third we see the final case where we get no solution at all. You can see over here that these two lines are parallel to each other. They do not meet each other at any point, which means they do not give us any unique solution. Neither are they sharing any number of points with each other. Now in this case we see the equation first. It is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. If we compare their ratios, we get a1 upon a2 is 1 upon 2, b1 upon b2 is 2 upon 4, and c1 upon c2 is minus 4 upon 12. So a1 upon a2 is equal to b1 upon b2, because when we simplify b1 upon b2 further, we will get 1 upon 2. But a1 upon a2 being equal to b1 upon b2 is not equal to c1 upon c2, because even if the signs cancel out each other because both are negative, 4 upon 12 will give us 1 upon 3, which is not equal to 1 upon 2. So we get a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. And when we get ratios in this order, we say that we do not have any solution, and such a graph is then said to be inconsistent. The first one, which gave us just one solution, we said it was consistent, okay, because it gave us a unique solution. The second one, which gave us infinitely many solutions, we said it was dependent. And the third one, which gives us no solution at all, we say that this particular system is inconsistent. So inconsistent system is a system of two linear equations in two variables wherein it has no solution. So this was about the graphical representation of a pair of linear equations in two variables. Finally, we move on to the algebraic methods, which you are more familiar with, which we use all the time, more convenient, more easier to find out the value of x and y. We use these algebraic methods directly to find out the value of x and y, and also if we are given word problems, then we can use any one of these methods. For the reduced syllabus this time, cross multiplication is not there, but otherwise there are three methods in which you can find out the values of x and y. First one is substitution, second is elimination, and the third is cross multiplication, which is not there. Eitherwise, you would have a choice between these three, and more conveniently these two can be opted for, substitution and elimination. However, for this exam where there is a reduced syllabus, you will probably have a choice between substitution and elimination. It is good to learn both of these, even if you would like to opt out of the cross multiplication method. So we'll go through the substitution and elimination method in details and just refresh our memory, although we have been doing that to solve for x and y in case of pair of linear equations in two variables. So the first algebraic method, substitution method, the name substitution means that something you have to replace in place of some variable. So substitution happens between the variables, one variable getting substituted for another. In case of substitution, what we do is we express one variable, say y, in terms of the other variable x in one of the given equation, whichever is convenient. Here if you notice, there are two equations, 7x minus 15y equal to 2, and the second one is x plus 2y equal to 3. And what we have done over here is from the second equation, we have kept x on the left hand side and taken everything else on the right hand side. Okay, so x equal to 3 minus 2y. So, and the next step, what we do is we take this x value which we have got, that is 3 minus 2y, and we substitute it in the other equation, not from the same equation that we got this value of x. Okay, that is from the second equation. We put it in the first one in place of x. So wherever there is x, that would be that is 7x, right? So in place of x, we replace it by 3 minus 2y, as you can see over here, and then we solve for y, and we see that we will get the value of y as 19 upon 29. Once we get the value of y, all we do is take this value of y, and then we can put it in the first equation that the equation that we got, x equal to 3 minus 2y. So in place of y, we put 19 upon 29, and then we will get the value of x, which is over here 49 upon 29. So general step, the first step that we do in substitution reaction is we express one variable in terms of the other variable x in one of the given equations, whichever is convenient. Second step, we substitute this value of y in other equation. Third step, we solve the linear equation in x obtained in second step. For the fourth step, we substitute this value of x that we have got in equation of step 1 to obtain a linear equation in y. And finally, the fifth step is when we solve the above linear equation in y to get the value of y. Okay. In the elimination method, we look to solve a pair of linear equation in two variables by eliminating one of the variables, either x or y, whichever is convenient to you. And in this, if you look, there are two equations over here, and what we try to do is whichever variable that we look to eliminate, we try to see that the numerical value of those of the coefficient of that particular variable is the same and the signs are opposite. If the sign is not opposite, then we look to change the sign, not just of that particular variable for one of the equations, but throughout the equation. However, in our example here we have x minus 3y equal to 6 and 2x plus 3y equal to 12. We've got 3y in both the equations and the signs are also opposite. We have minus 3y plus 3y. So we don't have to make the numerical value the same, neither do we have to change the sign. If you want to know more about how to carry out elimination problems, elimination method or substitution method, then the link to that will be given below. There is an entire playlist that you can go through to learn more in details about the pair of linear equation in two variables for class 10. Continuing further, so here we look to eliminate the variable y, and how do we do that? We just add the first and second equation. By adding the two, we are eliminating the y variable. The x variable gets added up, we get 3x, and the constants also get added up on the other side of the equal to sign, and we get 18. So 3x equal to 18, which means we get x equal to 6. Once we get x equal to 6, we can mark that as 3, and we can substitute this value of x equal to 6 in the first equation, where it says x minus 3y equal to 6. So instead of x, we put 6, okay, and if we take 6 on the other side, 6 minus 6 will become 0. So we get minus 3y equal to 0, and that would mean y becomes equal to 0, and hence we get the values of x and y, which is 6 and 0. So this is how we carry out elimination. This is how we solve for x and y by using elimination method. Substitution methods and elimination methods, that's what we are going to focus on, and this is another method which we can also use in order to solve for x and y. I'm not going to go into the details of this because it is not there for this particular reduced syllabus of Go About. So my cross multiplication method, and what is used over here are the coefficients, and the coefficients are cross multiplied, as the name suggests, cross multiplication, and we get them in ratios based on x variable, y variable, and the constant, and then we look to compare the ratios, and finally we will get the values of x and y once we cross multiply over here. So overall, this is what you need to remember and need to revise just before going for examination. This will give you a quick glance through this mind map will give you an idea what comes under pair of linear equation in two variables. I hope you found this video useful and hope it will serve very useful at the time of examination. If you like this video, please hit the like button, share it with your friends and classmates, subscribe to the channel if you haven't done so. Thanks for watching and keep watching for more such videos.